Hi, welcome back to my channel. My name is Gina. Today in this video, we're going to discuss why the Earth has seasons. Before I start my talk, let's take a guess. Comment below which one you think is correct. Seasons are caused by A. Earth's orbit around the Sun, variation in Sun-Earth distance. B. Tilt of the Earth's axis of rotation. C. Solar irradiance and sunspot activity. The answer is B. Tilt of the Earth's axis of rotation. All three choices are correct, and they all have some impact on the Earth's temperature. However, the second one, the tilt of the axis, is the reason why we have seasons. In this video, we're going to discuss all three of them in order. So let's start with the first one. Earth orbits around the Sun. First, let me explain how the Earth is rotating around the Sun. The Earth has both rotation and revolution. Rotation is the Earth is spinning itself, and revolution is the Earth is rotating around the Sun. And it takes 1 day for Earth to complete one rotation, and that is why we have daytime and nighttime. For example, this is the Sun and this is the Earth. The side of the Earth that is facing the Sun has daytime, and this part of the Earth has nighttime. And because it rotates once a day, so we have daytime and nighttime in a day. And it takes a year for the Earth to complete one revolution. So the Earth is spinning around while it's rotating around the Sun. And the Earth's orbit around the Sun is an ellipse. So it is true that sometimes the Earth will be closer to the Sun and sometimes it is further away from the Sun. However, that is not the reason why the Earth has seasons. The Earth is closest to the Sun on January and is further away from the Sun in July. However, July is the summertime for most of people on Earth. The reason why Earth has seasons is due to the tilt of Earth's axis. The Earth is not rotating upright, but this axis is tilted a little bit, so the Earth is rotating like this. As we can see from the previous slide, here the white line represents the tilt of the Earth, and we can see that in this image too. This is the tilt of the Earth's axis, and the Earth is rotating like this. And this angle of inclination between the Earth's rotation axis and its orbital plane is constant, which is around 23.45 degrees. And we said it's constant because it changes very slowly. It changes from 22.1 degrees to 24.5 degrees in 41,000 years. So the axis is always pointing in the same direction. So the orientation of the Earth's axis with respect to the Sun changes. And this also has an effect on the change in solar irradiance on Earth's surface at any given latitude. And that is the reason why we experience seasons. We define the solar declination as the angle between the direction of the Sun's ray and the equatorial plane. So the solar declination changes with latitude. And this solar declination at a given latitude changes with season because the tilt of axis remains constant. However, the Earth is rotating around the Sun. This tilt impacts incoming solar energy through spreading the sunlight, duration of daylight hours, and length of the atmospheric path. An example of spreading of light is when you hold your flashlight directly downward, then the light will be really focused and it will be really bright. However, if you tilt your flashlight and the light is spreading, then now the energy has to distribute over a larger area. So the energy received per unit area would be smaller compared to if you hold your flashlight directly downward. Similarly with the Sun, when the solar declination is higher, it means when the angle is greater, then the spreading of sunlight will make the total energy received per unit area smaller compared to if the Sun is directly above the Earth. The tilt also impacts the incoming solar energy through the duration of daylight hours. For example, here is in June, when the north of the axis is pointing toward the sun. So you can see that over the Arctic, even though the Earth is rotating, but it still receives the sun energy for 24 hours. So in the summertime in Northern Hemisphere, you can always see the sun in the Arctic even it's in midnight. And over the Antarctica, in June, it does not receive any solar energy. So it is always the nighttime over the Antarctica in June. However, in December, when the Earth is at the other side of the sun, now the Arctic does not receive any solar energy, and the Antarctica receives solar energy for 24 hours. And when a region on Earth receives solar energy for a longer period, it also means that it has a greater amount of total solar energy. So for the summertime over the Northern Hemisphere, not only that the spread is smaller over the Northern Hemisphere, but also the Northern Hemisphere has a longer daylight. That is why we call June, July, and August the summer over the Northern Hemisphere. And lastly, tilt also impacts incoming solar energy through the length of the atmospheric path. But this process is more complicated because the interaction of the sunlight and the atmosphere can have absorption, reflection, and scattering. For example, ozone absorbs the sunlight, which warms the atmosphere, and some other molecules, for example some clouds, will reflect some solar radiation back to the universe, and that will cool the Earth. Scattering will also reflect some part of the incoming energy back to the universe. So this is more complicated in the sense that sometimes a longer atmospheric path can warm the Earth and sometimes it can cool the Earth. Now let's talk about the last choice in the multiple question, the solar irradiance and sunspot activity. It is true that sunspot activity will change the total energy received by the sunlight. Here the lower right shows the number of sunspot activity and the x-axis is the time. And this pattern corresponds well with the solar irradiance that the Earth received. However, the period of the sunspot activity is 11 years. So this is not the reason why the Earth has season. That is the end of the video. I hope you find this video interesting. And I'll see you in the next video.